shall get started. My name's Daniel Thompson. I'm the tech lead of the support and solutions team at Linaro. I work in member services, and I'm here to talk to you today about upstreaming. So just to set you the context of what we're going to be talking about, today's focus is every bit on Linux kernel upstreaming. If anybody was in the talk from Sarah Sharp earlier, there's lots and lots of different ways that open source projects can be organized. And in this session, we're going to be focused very much on the Linux kernel. There are a couple of other projects who share a very similar culture. QEMU is one that springs to mind, U-boot another, where you wouldn't want to follow these protocols exactly, but certainly you would recognize enough of this kind of activity if you went to either of those projects. As you go further afield, mechanisms change much more and more. So we're going to look at upstreaming and what it is. We'll describe essentially kind of process mechanics, bits and pieces we're going to step through. And I don't really care who the target audience is because you're in here. But yeah, it's mostly going to be substantially technical. So we have a few prerequisites, which are basically that you, ultimately, when I talk about a git pull or sending patches, that you know what these things are. It doesn't matter if you don't understand how the race conditions of SMP work, that's irrelevant. So it's basic source control actions in Git, push-pull, sharing patches, things like that. That's all you need to know to follow what we're saying today. So again, in upstreaming for the Linux kernel, this means moving software to the kind of top-level Linux repository, which is the one that is managed by Linus Torvalds. One of the curious things about it is it's surprisingly hard to find. If you go onto git.kernel.org, you actually have to search for Torvalds as the name and scroll down until you find the Git repository because it's not highlighted any way differently to any other kernel maintainer's repository. So that's where you're going, and that's the repository that matters. That's the one that we call mainline and what we're heading for. There's a bit of dogma here. Lots of companies have a mainline, and they have lots of things, and when they talk about their mainline, they tend not to mean the mainline Linux kernel. They mean whatever they're trying to ship to their customers. So it's quite important to keep track of which mainline we're talking about. So this is the mainline. It is even marked as mainline when you're trying to download it as a tarball. And it will move through 4.5 RC, 6 RC7, and so on until it goes up to the next version number. Lots and lots of companies contribute to the mainline. It's probably less important over the years that we show this slide because more and more people now understand the benefits of mainlining and why people want to mainline in the first place. So this fall was originally added to kind of point out that there's so many names you recognize doing upstreaming, as well as quite a lot of consultancy companies who are generally taking on contract work from somebody else to upstream their code. But what you do notice is Intel is there, that Linaro is there, ARM is there in its own right. It has a big outfit of people doing the maintenance, particularly for the ARM64 work. And there's also plenty of representation from among the ARM ecosystem as well. So ARM is a very influential contributor to mainline as an ecosystem. Now when you're heading upstream, there's a hierarchy of repositories. You are not going to be sending code to Linus Torvalds to get your code upstreamed. You'll be working with subsystems. If you're writing a driver for a particular area, you'll tend to work with the subsystem maintainer for that driver. That subsystem maintainer may possibly even work with another subsystem maintainer where you get hierarchies. This is particularly if you look in areas like TTY, where there is the kind of base character device, then there's a collection of UARTs and other character devices all involved, and there's a tree of maintainers to handle that. But generally, most of the way through the Linux kernel, for the well-trodden path, when you're putting drivers for hardware that is not unique or magical, then there will be a maintainer for the subsystem you want to contribute to. When you head towards esoteric drivers, you might have the misfortune to need to introduce a subsystem, which is a long way outside the scope of this talk, but you do get a lot of maintainers who have become that because they were the first person to run upstream that type of driver. So we have here an example code flow. It's very, very small. You can probably only see the penguins, but I'll give you a quick point to kind of give some suggestions about what's going on here. So right at the top, we've got the Linus tree, and then we've got 3 different types of maintainer, because although in the SOC and silicon manufacturer community, what we think is really important are the drivers to make the thing come alive, there are lots of other things that go in to make up a kernel. So on the far side, over the far end, we've got feature maintainers. So there's plenty of hard computer science happening in modern kernels. There's the networking stack, there's particularly the file systems, there's block devices, device tree. All of those things are features that are used common to all kernels, but they are essentially software. There's not a great deal of direct interaction with the hardware going on at that point. And so that's one type of maintainer. Down the middle stripe, we've got architecture maintainers. So people like Russell King for ARM 32-bit and Will Deacon and Catalin for ARM 64. So there's architecture maintainers. If you're trying to add new architectural features, those are the sort of people you'll be talking with. So when particularly people get involved in virtualization, they quite often have to work with the architecture maintainers. Again, if you work for a SOC vendor, your fundamental bread and butter is going to be getting device drivers to work, which is this far side down here, where we've got that potential hierarchy of the subsystem maintainer, be it I2C or USB, big subsystems, and below that you have potentially big drivers. So DWC3 is the top one on that list, which is one of the very flexible USB cells, comes up in lots and lots of SOCs. So that particular single USB cell has a special maintainer who just looks after that cell. And if you've got that cell on your SOC, your driver contribution is adding whatever glue logic is necessary, and you'd send your driver to the USB peripheral maintainer. I didn't say at the beginning, actually, that I'll take questions as we go if anybody has any. So there's no need to sit quiet if you've got any questions about what I'm saying. Okay, so a maintainer, again, we've looked at what they have been in an earlier session, but they're essentially the people who own specific bits of component code, be it the subsystems, the drivers, file systems, and so on. And they're responsible for a specific slice of the kernel tree. Quite often, I mean, the file system structure of the kernel gives you the division into subsystems, so the way it uses directories is the fundamental way that things are divided up. And for the most part, they're the gatekeepers for the code. If you cannot convince them to take your code, it would be not impossible, but certainly as close to bypass. You have to satisfy the maintainer that the code that you want to contribute to their section of the kernel is the right piece of code and that it fits into place. And the thing that I say, I hope I'll get it in a few times during this presentation, is that maintainers are not all the same. There is a kind of standard process, which I think by and large we can thank Greg Coa-Hartman for formalizing. There's a kind of generic flow, but different maintainers do have subtly different working styles. And so one of the key things is to understand that upstreaming is a social activity of you forming a relationship with the maintainer while you're working with them. And so it's important that you recognize that they might have likes and dislikes that you can work with. Sorry, wrong way. Just to give you an impression of the number of maintainers, this is a grep that was run across the version 4.4 kernel. 1,087 kernel maintainers. And that includes catch-all maintainers, it includes maintainers of single drivers on particular architectures, but there are over 1,000 unique maintainers. And you can find them by looking in this maintainers file. It's got a very standard format. The format for the maintainers file is actually documented at the top of the maintainers file to help you. This is an ARM-related example where we see the M. Russell King is a maintainer for the ARM port. There is a list, L, that you should copy when you try and contribute code to that port so that other reviewers can get involved. There is a website that you could go to learn extra information. It's a very good idea to have a quick look at this site. If you're going to be touching code in Arch ARM, it's quite worthwhile having a quick look at that site, because Russell in particular has some extra processes that not all maintainers do, and he documents them on that website. And the S stands for status, it's the maintained. So some bits of code aren't maintained. They've the maintainers stopped volunteering to help, and it goes unmaintained and the status gets updated. As I mentioned, for driver writers, it's quite rare to bump into unmaintained code. And the F is the file system location for whatever is under maintenance. So when it ends in a slash, obviously it's covering the whole directory tree. So anything in the Arch ARM tree or any subdirectories is slightly more complicated than that, but yes, the essential search down does go depth-based. So anything in Arch ARM, Russell should be at a very minimum CC'd on. Now at this stage I'm going to shift slightly into the timing of things. It's very, very important to understand merge windows because there's a very common misconception, which is every 2 weeks the Linux kernel merge window opens and there's a frenzy of activity to throw code into the kernel. The only people who are throwing code anywhere during the merge window are maintainers. If you are not a maintainer, when you are trying to get code to people, it is not going to be in the 2-week merge window period. You are trying to share your code mostly during the release cycle periods, the early parts of the release cycle, so that those maintainers can review your change, find out if they approve on it, comment it, get it fixed up, and if they're happy, they can then apply it to their tree. Now, maintainers really don't like making Linus unhappy. So after release 6, maybe release 7, they will start to get more and more conservative about the changes they accept into their tree. Mostly, by release 6, they will have already shared the code they've merged into the Linux Next tree for testing. They'll have got reports back and they may be looking at bug fixes. But they will become more and more resistant to taking changes during the tail end of the development period. So once you're up to RC6, you're probably better off waiting. You can still share a patch. There's nothing wrong with sending a patch out at any time. But if you're actually trying to convince somebody to take that code, they're going to be most receptive in the RC2 to RC4 kind of period. And so yeah, typically less than 6-7 weeks after the merge window closes, that's the period that you've got to get everything landed. I say less, some kernel cycles are longer than others. So it's typically around about RC7 you get to. Sometimes if things are going well, there's only 6 released candidates. I think in the current 4.9 series, 4.8 series, there's an 8th release candidate. Which way am I going? Sorry. Yeah. So we've understood the merge window. We're ready to do some work. What we're going to do. So this is a quick summary of what we're about to talk about. I shan't read it out to you. Preparation. Fundamentally and most importantly, you need to know the content you are trying to put upstream. One phenomenon quite common in SOC vendors is the person who is tasked with landing it upstream is not necessarily the original author. The maintainer doesn't care. You're trying to get code up, you're the person with responsibility to fix it up. So it's a very good idea to understand the code you're contributing, even if it was written by somebody else. It's certainly important that you feel you own it enough to make changes to it, because the maintainer is very likely to ask for some changes. And you have to feel confident to make whatever changes are being made or resist changes if you think they're inappropriate. It's also very useful to know what's going on in related areas as you're working upstream. So there are lots of other SOC vendors. They have device drivers. They may share features with yours, they may not. But it's certainly a very good idea to keep an eye on other work that people are doing in that framework. And there's 2 reasons. One is the one written there, that it may possibly create API changes that you ought to be tuned into. The other one actually is you get to watch the maintainer interact with people. If you watch somebody else put in a change set that's very like yours, and the maintainer goes, yeah, awesome, I'll take that, don't worry. You look at the timing, you see what the other contributor did right, and you try to emulate their behavior as closely as possible because you know that what they've done is what that maintainer likes. So it is a very good idea to get in and watching what's happening in related areas. There are some very, very basic things that you should certainly not omit doing. You should read the documentation for the subsystem to get an idea of how it is used, what it's there for. You may get some clues, some testing from the documentation, the sort of testing that should be done. I've also written some bits in green here, well, grey possibly. This is very ARM specific. But if you are working on anything except perhaps an enterprise ARM64 system, you will be working with device tree at the moment. And there are additional complexities that come with working with device tree, and a philosophy of device tree that needs to be understood. And the philosophy of device tree is that it's not, let's say what it is actually. What device tree is it's a description of the hardware. It's not a description of what software features should be enabled or anything else. It is a pure, direct description of the hardware that the kernel can understand and work out how to initialize itself. And it's not Linux specific. Device tree is used by the BSDs at the very minimum. So if you put in a controversial device tree binding, you can expect the Linux maintainers perhaps to ping some of the BSD people to find what's going on. So for that reason, it is treated in a very special way. And it is worth both reading about the device tree bindings and how they're worked with, and also perhaps even sit on the mailing list a bit, because if you sit on the mailing list, you'll see lots of driver authors putting in device tree bindings, and you will see the device tree maintainers responding to them, and their responses can be very educational for you in working out what you need to do for your code. There is a lot. I've just told you now to go and read several mailing lists and look at the way other people are interacting with the maintainers. It's a natural way to understand the community. So there's obviously a question about which mailing list you can read. I mean, it is universally acknowledged that no one can possibly read the Linux kernel mailing list and remain productive. They probably can't read the Linux kernel mailing list and remain sane. There is just so much stuff going through it on a daily basis that you would simply never read it all. So you have to work out how to filter down to a level where you can gain enough insight in the community to feel confident when you come to send your code, but also keep yourself and the workload of reading your email to a low enough level. So one suggestion is to go into the Linux ARM kernel. That has the tremendous benefits that you'll see lots of device tree activity in it. It's very active. It's likely to be related. If anybody in the room is working for MIPS, then bad luck. But it's very likely to be related to what you're doing for a living. It's a good start. I mean, to be honest, it's still actually quite high volume. So I don't subscribe to this. I filter things down more than this, and we'll discuss that either at the end of this session or in the 201 session. The other thing is IRC channel. So it can be hard work to find IRC channels, but ARM Linux is a good starting point, and you might even see introductions there to other things. So as we saw in the last session, being on mailing lists is a good start, but for short, quick discussions, you can learn things on IRC. Okay, there are also lots of ways you can make what you might call a boring mistake. Your maintainers sit there and they will receive lots of contributions from lots of people, and they find it more exciting if you make a new and interesting mistake. So they have put in lots of documentation to try and stop you from making boring mistakes. So the very important ones at the top is the submitting patches. That's the document that describes how to prepare a patch and gives you advice on how to get the quality to a level that your mistakes are unlikely to be boring. There's a submit checklist, there's ABI. The device tree section has its own submitting patches because it has its own unique rules for how to submit patches for it. And then Greg Kirk-Hartman has created this long series of posts called How to Piss Off a Kernel Subsystem Maintainer, which documents, effectively, it's an interesting set because it's very time separated. It looks there like it was all written in one go, but I think it spans maybe 2003 to 2010. It's a very wide time interval it was written in. And it was basically the type of mistakes that people were making over and over again in that time period, and he was finding boring. And so he described how bored he was by these mistakes and tried to encourage people to make new and interesting mistakes. Wrong way, sorry. So having understood how to create a patch, or at least what processes you're going to use Git. I think this is probably obvious these days. There was a period where there was some ambiguity about what tools you might be best off using, and there were a few very senior kernel maintainers who didn't choose to use the source control tools of the day. But yeah, use Git. And learn how to use Git to make logical divisions of commits. The sort of advice, I mean, Git can be used to do partial commits, either using the GUI or using the -p feature. The -p is a patch, and it shows you the fragments of your code one at a time, and it allows you to, for example, split things out into multiple patches to get the sectioning correct. Each patch should be individually complete, by which it means that you don't break the kernel build at any of the intervening bits. It doesn't have to have made a functional change at each level. I mean, obviously, if you're putting a driver in until you've got the driver enabled in the def config and in the device tree, it won't actually function. But you can compile it separately, and bisectability, which is a way to search for regressions empirically, is a vital tool for hunting down bugs in Linux. And if you have patches that don't allow you to compile the code, that can frustrate that enormously. Again, the Linux kernel community norms are for very small patches. So when it says logical commits, easy review, speed acceptance, I actually find the opposite problem now. When I go to other projects, I split it up as a kernel developer because that's kind of instinctive to me, and I get told to squash them together. So yeah, the Linux kernel very much is the smallest possible change is a good change. If you've got 3 bug fixes, 3 patches. Although, if there are 3 bug fixes in a related area, you might choose to do it as a multi-part series. So if you've got a collection of things that are logically a feature, but they're broken down, you put them into a multi-part series, and that allows both different maintainers to take different patches from the series, and it also means that you can keep the patches as small as possible to keep everybody happy. The other things you do with patches is you version them. So the maintainer will have seen a patch, they will have commented on the patch, you will have gone away, you will have changed it, you will have sent in a new patch. If you don't version it, it's really hard for a maintainer to figure out exactly what has changed. They have to start renewing from scratch if they've invested time before. If they've invested a lot of time before and you've sent it in without a version number, they might well just ignore it. I mean, you compete for, I describe it as competing for maintainer attention. Patches compete with lots of other patches for maintainer attention. So if you do things to make your patch annoying to review, you are less likely to get the maintainer attention that you need. So you can see a version there. The other thing is that the norm is that if you're submitting a patch, you've put a signed off by the bottom, and the signed off by the bottom is implicitly saying that you believe that the patch is fit and ready to go into the kernel. So if you send in a patch and say, actually this is a bit broken, can you help me to figure out what I need to do to change something? Or am I doing it right? Or is this the best way to solve the problem? Then you tag it with RFC. It means it's request for comment. And it's a request basically saying that you think this patch isn't quite right, but you would appreciate advice or comment or enthusiasm or help. It's a very good way to get things. Now, what you will also hear as you go in is there are maintainers who are very busy and are filtering out all the RFC stuff. It's true, some maintainers do filter out RFC stuff and will never see it. But there are other developers in and around that subsystem who will see it. So despite the fact that some maintainers filter out RFC stuff, it is still worth having that tag in if you don't believe your patch is fit for inclusion as you're sending it, if you're seeking that advice and help. The commit message matters. This is, I'm so indoctrinated I can't see why this is controversial, but a lot of people do think, well, I've got the code, it looks perfect, I love it. The commit log is describing the benefit of the patch, and the key thing it's trying to do is to explain why the code that you're committing is worth putting in the kernel in the first place. So it's a very good idea to put a lot of attention into the commit messages, spell them correctly. Simple spellings will be picked up and you'll have to respin the patch. So there's an example there of the sort of commit message you could use. We'll also again discuss a little bit later some examples of really good and really bad commit messages. One of the reasons to use Git, among many, are the benefits of this format patch tool. Actually, that's a thing to observe, yes. Having said we talk about Git pull requests and all these things, pull requests are mostly used between maintainers to share code. Any contribution you make should almost always go into the mailing list as a patch. And this is an area where, for example, Linux and many other projects differ. Many other projects use Gerrit or GitHub to manage pull requests, and the review processes are assisted with web tools. The review processes for the kernel are assisted using mailing list tools. So you send patches to the mailing list. --minus cover letter is important if you're sending a multi-series patch, because that will allocate you a patch 0 where you can describe the purpose of the entire set and you can fill it in. Once you've generated your patch set, run it through check patch, because that will pick up, again, boring mistakes. The kernel people are very used to getting boring mistakes, and check patch is there to filter out a large number of boring mistakes and common misspellings. It's got a collection of ways in which people misspell things, and it will remind you that you spelt it wrong and tell you how to fix it. And then finally, once you've got your set of patches and you think it's ready to go, there is a tool to scan the maintainers file and help you figure out who to send that patch to. And so you can use your tool to get the maintainers, and then you send out your patch. So you put the maintainers on the to list, and you put mailing lists typically on a CC, and if there are other interested parties, so there might be reviewers that come up out of the maintainers. In certain areas where there aren't very many people involved, check patch will go and search through the history of the patch, looking for people who have contributed to the same driver. If you're working in frameworks, it will look for other people in the Git history to see who's worked on it. And if you can see somebody who's written lots and lots of code in that particular file that you're altering, you might choose to put them on CC, because as the original author of that code, their reviewed by tag is useful in terms of getting the code upstream. There's then even a tool, git send email, which will help you post the patches once you've created them without making any kind of boring mistakes at the mail user agent level. Git send email is pretty configurable. You can connect it to, password controlled ASMTP servers and things like that. You can configure it in a variety of ways. And then you sit back and you wait for those comments to roll in. Expecting comments doesn't really mean, expect comments straight away. It more means that it's not a bad thing if somebody asks you to change it. If they've asked you to make a small change, what that implicitly means is they've read the code and they don't think anything else in it needs to be changed. If they say you've done it completely wrong, at least you've got it out early enough and you can start working in a new direction. So when it says expect comments, it's more being, be receptive and listen to comments when they come back. And the reason, it isn't actually that uncommon to get no response. Certainly not quite as fast as you might like. Be patient. Maintainers are very busy, and particularly during the merge window, they are tremendously busy trying to get the code into Linus and fix any last-minute bugs before you get the RC1 out. So yeah, my advice actually is don't ever beg somebody to pay more attention to your patch while the merge window is open. It's quite often regarded as bad manners. There's even in the past been some debate about whether you should send patches at all during the merge window. The conclusion of that debate was that you can send patches during the merge window to most maintainers. But yes, you certainly should not say, ping, have you looked at, can you have a look at my patch? But anyway, if you wait a week and it's not, the merge window isn't open, you can send effectively a resend. So in all those tags we had before, patch, RFC, versioning, you can also add the word resend just to remind people that you're still there and you'd like some help. So yeah, keep an eye out for tough questions. You are going to have to justify the decisions you've made, and this is the reason why I suggested you should know your content. Maintainers aren't always correct, though start by assuming they are unless you can construct an argument by which they're not. You need to be able to express disagreement with facts, as I think Sarah mentioned earlier. You need to be strong, you need to be clear. You need to make, you can make technical arguments if they've suggested that some way is faster and you've already benchmarked it. It's a very simple reply. You say, I've benchmarked that already and I've done like this because it was faster. But yes, if it's a matter of taste and you can't create a fact, then just follow the matter of taste. If you can't have a clear argument as to why the way you want to do it is better, make the change as requested. If you don't understand why they've asked you to do something, it's absolutely fine to ask for clarification. You can have some very useful dialogue with maintainers. It's ultimately a form of relationship building. So if you get comments you don't understand, it's very sensible to ask for clarification. Don't make assumptions. And very critically, don't ignore comments. The convention on the mailing list is that an unreplied point is correct. So when people are having debates, typically it's assumed by and large, except perhaps in serious flame wars, that the last comment is the kind of final word. It is the agreed position. So if you don't reply, what that means is you agree with everything the maintainer has asked you to do. I mentioned using a sane email client. When you've used git send email, you've already sent everything out in the right order, but in order to engage with the discussion with the maintainer, you need to follow the conventions used by the community, and they are ASCII-centric. Actually, no, they're not. They're probably Unicode-centric, but they're certainly text-centric. It's not HTML. It's plain text, typically wrapped to a fairly narrow width so that when you quote it, it doesn't start overflowing an 80-column terminal. It's a good idea to have threading working so that when you make a reply, most maintainers will be using threading email clients to keep track of what's going on with the various comments that's been made. Again, boring mistakes, don't do them. There is a document called Email Clients helping you find email clients that aren't going to cause trouble. It's actually getting along the tooth. You see things like Pine in there and so on. I'll confess I personally use Thunderbird with everything wedged into text mode. It's not that you can't use modern GUI emailers, it's that you have to make sure they're appropriately configured. And again, the documentation on it will help you configure it correctly. Don't worry about getting flamed. I mean, of all the things that can go wrong in the world, being flamed by a maintainer is both very unlikely and also not the end of the world. So yeah, follow the document practices, try not to make boring mistakes. If that's the other thing, I mean, I've made plenty of boring mistakes in my time. Quick apology is one of the best corrections you can offer. You know, be reactive. When somebody's giving you feedback, whether it's technical or social, if they said you're acting like an idiot, don't do that again, then you say, yeah, sorry, I won't do that again. It's enough to clean things up, to acknowledge mistakes. So when you've had these things, it's best to be as responsive as you can. While the issue is still fresh in people's mind, that is the point when you replying quickly can get resolution quickly. You know, the faster you can turn a patch around and react to the feedback that you've had from maintainers and other reviewers, the more quickly and more alert everybody is. It can also get you through multiple iterations much more quickly. You know, you've only got that 3-week, 4-week period. So yeah, if you release at RC2, you've got to make agreement and complete everything by RC5. So the faster you iterate, the better. Make sure when you resubmit that there is a version number, and the common convention is to include a changelog so that a maintainer or anybody else can very quickly whiz down the patch and check that their feedback has been incorporated. And now it's been accepted. Yay, we're done. Right, we'll go on merrily go on with the rest of our lives. It's a good idea to stay around. Keep your emailer connected with appropriate filters to keep an eye on the code that you've written. There may be contributions. Somebody else may want to extend your driver, fix your driver, and so on and so forth. If you're there to review what they've done and send your act by, it's a nice contribution. It encourages further changes of things. The other thing is testing. You're the SOC vendor. Nobody is more motivated than you to keep your SOC working. While when something goes upstream, if APIs change, people will tend to automatically change your driver to conform to the APIs. They won't have tested it. They won't know it still works. Keeping it tested is usually a good job for you to do. So we have a summary at this point, which is the kind of iteration of everything I've spoken about. Putting that time in preparing, understanding the processes you're going to take part in is a good idea. If you can, find something small to work with. Find a driver that is where there's lots of them, where there's lots of prior art to copy, where there's not any innovation happening. If you can, you probably don't understand what a UART does. If you can avoid making the UART your first driver, that's a good plan to do. It doesn't matter if you do a UART, but there's a lot of strange and esoteric things in UART drivers. Strange areas of POSIX compliant in the no replies and things like that. If you can pick a different driver, do. If you can't, UART is obviously one of the most important drivers because it's one of the kind of 4 or 5 things you have to do to get basic boot from RAM disk working. But if you can avoid it being the UART, so much the better. Ask questions. You know, there's nothing wrong, there's nothing dishonorable about asking for help on the mailing list, providing you're doing it in an appropriate way with the right email client. And reacting quickly and understanding the merge window. So I will pause for comments at this point. If anybody has any questions, now is an excellent time to ask them. I do have some more material, but if there's anything burning in people's minds, now is a really good time to ask. There's a microphone coming.
You talk about change logs in a patch series that you have multiple revisions on. Do you have an example of what you mean in terms of change log?
I think that will come up in 201, I hope. I mean, it's a free-form text. Most people have their own personal style. So I tend to put the version of the patch, so v2 : and then I've just created a bulleted list of the changes I've made. I quite often follow each change with a bracket describing who submitted that change. So who requested the change. Because again, that means reviewers can scan down, look for their name, and they might be done. It just saves them time. So my personal preference is to include the name of the person who requested the change, both to credit them and to make their job more easier to look at things. But it is free-form text. So a tag and a bulleted list is a very sensible and easy way to do it.
Thank you.
You mentioned patch series, and how do you determine a method of partitioning your patch into series? I mean, what?
Can I take the driver example? Drivers are very easy. So if you're writing a patch series to enable a particular driver, let's take a UART. If you're writing it for ARM, then you will need to introduce the device tree bindings. You will need, to document the device tree bindings. Because the first thing in all patch sets, we're going to come to this in a minute, but is to have the device tree bindings. You'll need the driver itself. So that means the driver and the changes to the make file to cause it to compile. You might need another patch to change the def config. So if you want this driver to be enabled by default, that you don't put those in the same patch because they're owned by different people. And also, you will need then to have a patch to modify the device tree so that your driver is able to bind when you load it with the right device tree. So that's a simple partitioning. I mean, there are other much more complicated examples. To be honest, if it gets grey, maintainers will comment on your partitioning as much as anything else. So for example, I've got a complicated architecture patch that I'm working on at the moment, and I lovingly partitioned it as carefully as I could. I made it as logical as I could, and I was asked literally to slice the thing in two and call it 2 separate patch series because it makes some pretty fundamental changes to the way the OS works on an ARM. So they wanted to have the fundamental changes in one thing and the features in somewhere else, so that they could do a kernel cycle with the one thing in it and then follow it up. But the maintainers helped me with that. You know, I submitted it the way I thought was right. I was asked to partition it. I did actually challenge the maintainer who suggested I split it up. He came back with very, very good reasons for me. So yeah, you can be fairly relaxed about it. And in the next session, we will also go into a bit more detail with examples of constructing patch sets. Well, like I say, you can put your hands up any time if you like, but I do have some preview material. What I've done is for this training session this year, I've added some new material. This is quite a course we've been running in the same form quite a number of times. I've added lots of new material, and I haven't done my timings in advance, so I've added a bit of tacked on material to each presentation so that I can overrun or underrun and still get onto it. Before we do that, I should like to say this is a gimmick, but this presentation comes with a lifetime warranty. So anybody in the audience here today who at any point wants to discuss anything that's come up in either session, there's an email address there which will be active for essentially as long as Linaro is, with people to help you. It goes to my team. You'll be surprised how many senior people you'll be copied in, but yeah, it'll go past my desk. It will go past the desk of most of the people on my team. and yeah, we will help you. I was going to say, if you work for a group member, club or core member, you can even go outside the scope of the presentation. You know, for members, we will put extra effort in. Club and core members, we can even do help and specific mentoring. So yeah, it has a guarantee. If you want to talk to me about it in the future, please do. I would appreciate the feedback. Okay, so this is a preview for the next session. Effectively, I'm assuming that because these sessions are so closely related, I shan't get many people for the next session who aren't sitting in this one. So I'm going to preview some of the material that's really closely related to what I've been talking about. And that's this filtering of mailing lists. Lots of people filter mailing lists in a lot of different ways. Why's that gone blank? Yeah, there we go. Excuse me a moment. Oh, there's an extra page. There we go, I beg your pardon. Right, so I know I'm around now. Yeah, why do we filter the mailing lists? Well, fundamentally, because you can't not filter. You have to find a way to filter because there's too much information for you to absorb any other way. But one very simple technique is to subscribe to the full Linux kernel mailing list and filter it really aggressively. And that means taking out the vast majority of the context and using those aggressive filters so that you're focusing on the areas that really interest you, based on whether that's your personal interests. If you're a manager, you can use it to watch what's happening in your team. If you are a normal engineer, you can use it to watch related subject areas. If you're working on the UART driver, you can watch other people submit UART drivers. So the good habits, if you're filtering the mailing list, is to have a whitelist. You don't want to filter out what you're not interested in. You want to filter in what you are interested in, and you just delete everything else. Don't try hoarding it. You know, your hard disk can be used for other things. All the stuff that happens on the mailing list are available from search engines. And it's a lot easier to search with a search engine. Google is much better at searching text than whatever emailer that you possibly could find. I like to have a filter that keeps an eye on code that I've contributed, so that if it slips through any of my other filters, the fact that it's a file that I worked on will pick it up and show it to me. Have a look at the Git log for drivers in the directory you're interested in, and you will notice that they start with a collection of tags, like tty:\uart, for example, if you're working on a UART. So you have a quick look at the logs for the directory that you were interested in looking at, and you'll get a feel for those tags, and then you put those tags on your whitelist so that the driver of interest to you comes up in your mailer when you're looking at it. And the final thing is, assuming you are a fairly curious person, you will still get quite a lot of email because you'll have ended up subscribing yourself to quite a lot of stuff. So you now have to cope with that volume of email, and it's very tempting to write a filter now to take all that stuff and throw it off into a side email address, you know, a separate email box, which you then never read, and you then delete every 2 months, everything from it, and start again. So I prefer to keep that in my normal mailbox flow, and I don't hide it from myself. I use marks or colorization so that email to me, or CC'd or to, it shows to me in a different color than stuff off the mailing list. And the way that's great is that allows me then to filter very quickly. You know, I can look at the subject line, and if the subject line interests me, I can read it. And because it's a separate color, if the subject line doesn't interest me, I don't have to even open it. I can delete it without looking at it. So that's the personal rule I think you should add to yourselves if you're doing this kind of filtering, is that for tagged email, you just press delete straight away if you're not interested. The final detail actually is that make sure that you are only hiding mailing list traffic from yourself, because if you've contributed code, you will now be on the CC list of another patch that may be of interest to you, and it's important that if you're in the to and CC list, that you highlight it for yourself so that you don't quickly skim through and delete it, because you probably need to get involved in the renew for various reasons. If that makes sense, I'm not sure I've explained it as best I could, but you know, I personally have a colorization filter that picks out to and CC and marks it as important, and then I have things that spot stuff on mailing lists and mark it explicitly as unimportant. But if I'm on if I'm on to or CC, and it comes to me via two routes, mailing list and direct, I will still see it clearly, and it will pop out for me in my mailing list. There's even a really, really cunning and clever way to achieve all this filtering, no matter what clients you're compelled to use in your working environment, which is you can create yourself a specialist Gmail account. This is entirely optional. No maintainer is going to say, oh dear, you didn't use a special Gmail account. This is, if you like this idea, it's a neat one to copy. You can create a special Gmail account, you subscribe it to Linux kernel mailing list, you configure it so it's allowed to forward to your work email account, and then you put the filters expressed in the Gmail form, and then anything that you want to see will automatically be forwarded to your work account where you can pick it up. And it also gives you this fantastic colorization opportunity, which is you can colorize messages by looking for a specific header to show that it was forwarded by Gmail to you. And that solves the to and CC problem mentioned before, because anything that's to and CC will land in your normal work account and can't get picked up by that filter. So it's a little bit more complicated to set up than getting Thunderbird to do it for you, but it's a very nice and clean way to manage the volumes of email that are going to come into you. And with auto delete set, you still get the opportunity to do a quick search through 30 days of thing using all Google algorithms. And if it's older than that, you use the web copies. The other area of socialization that I should talk about is IRC. IRC is also where kind of small things happen. A lot of maintainers hang out there. It's a chance to discuss things with them. But it is difficult to figure out which particular IRC channels to join. So you can start with ARM Linux. It's a good sane default. You can also search for mailing list, IRC. But unfortunately, IRC channels are not mentioned in maintainers. So you can't go and look down maintainers and find out which IRC channel is going to be interesting. You can search for patterns. So this, for example, looks for Linux-M, which I think was when I was looking for something to do with Qualcomm, where the MSM keyword is quite popular. So yes, a lot of Linux IRC channels start with word Linux, and it does give you that opportunity to try and find interesting IRC channels. On IRC, it's absolutely fine to sit and watch. Lurking is perfectly well tolerated. They're big IRC channels. The only really important thing on IRC is if something does become interesting and you do want to ask a question, don't seek permission. It's another boring mistake. Because IRC channels are, slightly time separated, they're not absolutely instant for people unless they've been tagged. Then, just ask a question and see what comes in the reply. Use this with care, but it can be a way to follow up on code reviews as well. If somebody's sent you a review and you've replied that you don't understand and you still don't, and you just don't seem to be communicating well on email, you can pop up on IRC and ping them and say hello. I can feel quite safe disclosing this to a room of people who are coming up to speed, because it takes you a while to figure out how to connect an email address and an IRC tag. And by the time you've done that, you're probably not going to abuse that information. And at that point, that is the conclusion of the material in the 101 session, and we're running almost perfectly to time. So if there are any closing questions, we can do that. Otherwise, there is a 20-minute break and a resumption for the 202 session in 20 minutes. Thank you.